Hello student, in previous lecture we have discussed the method of Lagrange's multiplier and one example how to solve or how to obtain an extreme value of the given function f of xy subject to the constant g of xyz equal to 0. In today's lecture we are going to see some example on the method of Lagrange's multiplier. Consider first example. Divide the number 36. Divide the number 36 into 3 parts so that continue product of first square of second and cube of third may be maximum. Okay. So what we want to do here? We want to divide a number 36 into 3 parts, but there is a condition. 36, so that our the continuous product of first, square of second and cube of third may be maximum. That is, we want to maximize. Suppose x, y and z. Suppose x, y and z be such a number. Okay. Then what is given? X plus y plus z is equal to 36, and we want to maximize f of x, y, z is equal to the continuous product of first, square of second and cube of third may be maximum. That is, we want to find a maximum value of this function f of x, y, z, which is what? X, y square, z cube. Okay. Continuous product of first, square of second and cube of third may be maximum. If there is a condition is not given, then you can easily obtain this will be the maximum value. Okay. But here there is some restriction on x, y, z. That is, this x, y, z also satisfy this condition. That is, x plus y plus z must be 36. So there is some restriction is given or constant bound is given on this x, y, z. Okay. So here to obtain extreme values of here, we are going to apply a Lagrange's method of multiplier. So here, consider an auxiliary equation. F is equal to f minus lambda g. So this implies capital F is equal to x y square z cube minus, I'm writing here, capital F is equal to x y square z cube minus lambda times x plus y plus z minus 36 is equal to minus 36. That is, what is your g? G is equal to g of x y z is equal to x plus y plus z minus 36. So this is g and this is here. So this is an auxiliary equation. If we put f and lambda g, we will get an auxiliary equation. Now to find a critical point, consider first equation f of x minus lambda g of x is equal to 0. F of x minus lambda g of x is equal to 0. This implies y square z cube minus lambda is equal to 0. The partial derivative with respect to x is what? 1. Here y square z cube. Second equation, so this is equation number 1. Equation number 2, f of y minus lambda g of y is equal to 0 implies, what is the derivative with respect to y? Twice x y z cube minus lambda is equal to 0. So this is equation number 2. Derivative with respect to y is what? 1. Again, f of z minus lambda g of z is equal to 0. This implies 3 times x y square z square minus lambda is equal to 0. So this is equation number 3. And last, g is equal to 0 implies x plus y plus z is equal to 36. So this is equation number 4. So by using equation number 1, 2, 3, 4, we are going to obtain some relation between x, y, z, or we are going to find a value of lambda. So there are two ways you can find value of lambda, or you can find a relation between x and y and z. I am going to discuss here both the methods. So that is, you can use any logic to solve these four equations for x, y, and z. So first logic is what? First, multiply first equation by x, multiply second equation by y, and multiply third equation by z. So if you multiply, that is x into 1 plus y into 2 plus z into 3, okay, then you will get, if you multiply here x, here y, here z, you will get x y square z cube, x y square z cube minus x lambda is equal to 0. Then second, 2 twice x y square z cube minus y lambda is equal to 0. And third, thrice x y square z cube minus z lambda is equal to 0. If you multiply this equation by z, this equation by y, and this equation by x. So if you add these three equations, you will get 1 plus 2 plus 3. It is equal to 6x y square z cube minus lambda times x plus y plus z is equal to 0. But what is the value of x plus y plus z? It is equal to what? 36. So what this implies? 6x y square z cube minus 36 lambda is equal to 0. If you take 6 outside, you will get x y square z cube minus 6 lambda is equal to 0, and this implies lambda is equal to x y square z cube divided by 6. So this is the value of lambda. Okay, this is one method, and if you put this lambda, if you put this value of lambda in equation number 1 will get y square z cube minus, what is lambda? Lambda is what? X y square z cube divided by 6 is equal to 0. Okay, if you substitute this value lambda in these three equations, you will get the value of x, y, and z, where your function here may be a maximum, and that x square z also satisfies the condition x plus y plus z is equal to 36. So from this equation, you take y square z cube outside. What is left? 1 minus x by 6 is equal to 0, but y square z cube is not equal to 0. If your y square z cube is equal to 0, then x equal to 0, y equal to 0, z equal to 0, and it does not satisfy the equation x plus y plus z is equal to 36. So this term is not equal to 0, implies 1 minus x by 6 is equal to 0, but this implies x by 6 is equal to 1, and this implies x is equal to what? 6. So we obtain the value of x is equal to what? 6. Similarly, if you put your value of lambda, if you put the value of lambda in second equation, in this equation, you will get twice x y z cube minus lambda x y square z cube divided by 6 is equal to 0. So from this equation, if you take x y z cube outside, what is left inside the bracket? 2 minus y by 6 is equal to 0. But again, this term is not equal to 0. Okay, already I have explained why this term is not equal to 0. If this term is 0, implies x is 0, y is 0, z is 0, and it does not satisfy the equation x plus y plus z is equal to 6, or it does not obtain here the maximum value of f of x, y, z. So what this implies? 2 minus y by 6 is equal to 0, and this implies y by 6 is equal to 2, and this implies y is equal to what? 12. So x is equal to 6, y is equal to, I am writing down, x is equal to 6, y is equal to 12, and now similarly, if you put your value of lambda in third equation, then what is third equation? 3 times x y square z square minus lambda is what? X y square z cube divided by 6 is equal to 0. So again putting this x y square z square outside, this 3 minus z by 6 is equal to 0, but again this term is not equal to 0, implies z by 6 is equal to 3 and z is equal to what? 18. So here we have obtained the critical point x, y, z is equal to 6, 12 and 18. So these are the critical, this is the point, these are the values of x, y, z, where this x, y, z also satisfy x plus y plus z equal to 36. If you take the addition of this term, it is 18 plus 18, 36. And which maximizes the function f of x, y, z. What is the maximum value? The maximum value is equal to f of x, y, z is equal to x, y square, z cube. So it is equal to x is what? 6, 12 square, and z cube is what? 18 cube. If you simplify this, it is equal to, this value will be, if you use your calculator, this value will be 38 84 8. So this is the maximum value of f of x, y, z. Now this is one technique, that is we multiply this equation by x, y, z, and then we find the value of lambda, and then by using this lambda we obtain the value of x, y, z. This is one technique. And the second one is what? The second technique is, okay, you can apply any one of the technique, that is or you can develop your own technique to find the relation between lambda, or find the value of x, y, z. In first method we multiply the equation 1 by x, then by 2 by y, and 3 by z, and then by using that we obtain the value of lambda, and by using that lambda we find the value of x, y, z. Now what is the second technique? From the equation 1 we can write lambda is equal to y square z cube. From the equation 2 we can write lambda is equal to twice x, y, z cube. And from the equation number 3 we can write lambda is equal to 3 times x, y square, z square. 3x, y square, z square. Okay. By using equation number 1, 2 and 3. So one side is equal. Implies other side is also equal. So y square z cube is equal to twice xy z cube. So this y z cube get cancelled here. One y get cancelled here. So we get the relation is here 1 is equal to y is equal to 1 y get cancelled here, 1 y. So here y, z cube get cancelled here. Okay. Then 1 y will get cancelled here. Y is equal to twice x. Y is equal to what? Twice x. One relation. Similarly, if we consider these two equations, since one side is equal, left hand side is equal, this implies right hand side should be equal. So twice xy z cube is equal to thrice xy square z square. So what this implies, this xx get cancelled here. Then what happens? One y will get cancelled here, z square, and one z is get cancelled here. So twice z is equal to thrice y. Twice z is equal to thrice y. So from this we will get z is equal to 3 by 2 y. Z is equal to 3 by 2 y. So x is equal to what? 1 by from this we obtain x is equal to 1 by 2y. Okay, so up to this we have applied equation, we have used equation number 1, 2 and 3. By using equation number 1, 2, 3, we obtain some relation between x, y and z. That is y equal to twice x implies x is equal to 1 by 2y, and twice z is equal to 3y implies z is equal to 3 by 2y. Now what is equation number 3? 4. What is equation number 4? X plus y plus z is equal to 36. But what is x? It is 1 by 2y plus y plus what is z? 3 by 2y is equal to 36. So if you add these two equations, 1 by 2 plus 3 by 2 is 4 by 2, and 4 by 2 is what? 2y plus y is equal to 36 implies 3y equal to 36, and this implies y is equal to 12. Y is equal to 12. Now y is equal to 12 implies, if you put here x is equal to 12 divided by 2, it is what? 6. X is equal to 6. And if you put here z is equal to 3 by 2y, then what is z is equal to 3 by 2 into what? 12. That is what? 6. 6 times 3 is what? 18. Again we have obtained the same answer, x is equal to 6, y is equal to 12 and z is equal to 18. But this method is more simple as compared to previous method. Okay, so try to evaluate by obtain, that is by using obtain some relation between x, y and z. This method will be more simple as compared to the previous method. So now take one more example. Obtain shortest distance of the point 1, 2, minus 3 of the point 1, 2, minus 3 from the plane twice x minus 3y plus 6z is equal to 20. So now obtain the shortest distance of the point 1, 2, minus 3. Means what? You want to determine the perpendicular distance from this point to this plane. Okay, what will be the shortest distance from this point P is equal to 1, 2, minus 3 to this plane? Now suppose let x, y, z, suppose P is equal to x, y, z, be any point on the plane twice x minus 3y plus 6z is equal to 20. Okay, then what is the distance from this point to this point by the distance formula? By the distance formula, d is equal to distance from this point to this point is x minus 1 bracket square plus y minus 2 bracket square plus z plus 3 bracket square. So we want to minimize this function. Okay, so we will get the perpendicular distance from this point to this plane. So I am writing here d square, which is our f of x, y, z, is equal to x minus 1 bracket square plus y minus 2 bracket square plus z plus 3 bracket square, subject to the condition, that is this xyz must also satisfy the condition g is equal to g of xyz is equal to twice x minus 3y plus 6z minus 20. So instead of writing square root, I am saying here d square, which is what our f of xyz. So consider an auxiliary equation f is equal to f minus lambda g, where lambda is the Lagrange's multiplier. So capital F is equal to x minus 1 bracket square plus y minus 2 bracket square plus z plus 3 bracket square minus lambda times twice x minus 3y plus 6z minus 20. Okay, now to determine and value of x, y, z or critical point of x, y, z, we have to consider an equation. First equation f of x. Consider an equation f of x minus lambda g of x is equal to 0. F of x consider an equation f of x minus lambda g of x is equal to 0. This implies what is f of x? It is derivative of this term with respect to x, 2 times x minus 1, and what is the derivative of this term with respect to x? It is minus 2 lambda is equal to 0. Derivative of this twice x with respect to x is what? 2. So this is equation number 1. Then what is second equation? F of y minus lambda g of y equal to 0. This implies derivative of this term with respect to y, 2 times y minus 2 minus the derivative with respect to y is what? 3 lambda. So minus minus become plus, 3 lambda is equal to 0. So this is equation number 2. And third, f of z minus lambda g of z equal to 0 implies 2 times z plus 3 and derivative with respect to z is what? 6. So minus 6 lambda is equal to 0. So this is equation number 3. So and last equation number 4, g is equal to 0 implies twice x minus 3y plus 6z is equal to what? 20. So this is equation number 4. So by using equation number 1, 2, 3, 4, 5, either we want to obtain some relation, want to determine value of lambda. This is one method. Also, what is the second technique? Either by using this 4 equation, find some relation between x, y, and z. So from equation 1, we can write lambda is equal to x minus 1. That is, this 2 will get cancelled here. If we take lambda on that side, we will get lambda is equal to x minus 1. From this equation number 2, we can write lambda is equal to minus 2 by 3 y minus 2. And from equation number 3, we can write lambda is equal to if we take this 6 on that side divided by 2, then it is 1 by 3 z plus 3. So we have solved this equation for lambda. That is, we take this lambda on right hand side. So if you observe, one side is equal, that is left hand side equal. What this implies, RHS must be equal. So x minus 1 is equal to minus 2 by 3 y minus 2. From this we will get x minus 1 is equal to minus 2 by 3y, minus become plus 4 by 3. So from this we will get x plus 2 by 3y is equal to x plus 2 by 3y equal to 4 by 3 plus 1. Okay, and from this we will get x plus thrice x plus 2y divided by 3 is equal to 3 plus 7 by 3. So from this we will get thrice x plus 2y is equal to what? This 3 will get cancelled here. 3x plus 2y is equal to 7. And from this we obtain the value of x, that is x or y. X is equal to 7 minus okay, x is equal to 7 minus what? 2y divided by 3. So this is one relation between x and y. Similarly, if you find the relation between, if you consider the second equation, what is second equation? The second and third equation, that is minus 2 by 3 y minus 2 is equal to 1 by 3 z plus 3. So this 3 will get cancelled here, and y minus 2 is equal to minus 1 by 2 z plus 3. So again, if you simplify this, we will get y is equal to minus 1 by 2 z, then again minus 3 by 2 plus 2. So if you simplify this, y is equal to minus 1 by 2 z. Sorry, we want to determine z in terms of y, because we find here x in terms of y, so we want to also determine z in terms of y. So to determine z in terms of y, what we want to do here? We want to we can write this is equal to z plus 3 is equal to minus 2 times y minus 2. So z is equal to 3 minus 2y plus 4. So z is equal to 7 minus 2y. 7 minus 2y. So here we obtain the relation between x and z in terms of y. Now use the equation number 4. So what is equation number 4? Twice x minus 3y plus 6z is equal to 20. So if you use this equation, then twice x. So what is the value of x? It is equal to 2 times 7 minus 2y divided by 3 twice x minus 3y as it is, y as it is, plus 6z. What is z? 7 minus 2y equal to 20. So if you simplify this, we will get 2 times 7, it is 14, minus 4y divided by 3 minus 3y plus 42 minus 12y is equal to 20. So if you simplify this again, we will get 14 minus 4y divided by 3 minus 15y plus 42. If you take that 42 on this side, you will get 20 minus 42. So this is equal to 14 minus 4y minus, if you multiply these 3, this by 15, we will get 45y divided by 3. If you take 3 on that side, you will get minus 22 into 3. So if you simplify this, we will get minus 4y minus 44y. It is equal to minus 49y. And if you take this 14 on this side, we will get minus this 66 minus 14. So minus 49y is equal to minus 80. So what is y? Y is equal to 80 by 49. So this is the value of y. And then by using a relation between x and z in terms of y, find the value of x, y and z, and then put that value x and z in our square root formula, distance formula, you will get the minimum distance from that point to plane. So here we are going to